All right, I win. Slides are. Okay, so I'm John Graham. I've been working for Tom and Larry for almost 7 years on Pacific Research Platform and beyond. Let's see, how do I drive this thing? So the Pacific Research Platform grew out of starting to do disk-to-disk testing across most of the campuses in California, along with a couple other NASA Ames, NCAR, supercomputer centers, and Tom and Larry reached out to a whole bunch of researchers and IT specialists and got letters of commitment. Apparently, get it in writing and it works. And our goal was to move our data transfers to much faster. We found complexity was killing us very quickly. Trying to manage so many machines across a wide area. So we picked up on Kubernetes early in its life, and everybody knows it's everywhere now. We are a science social network. And so one of the things that we do is we support our users via chat. Get this presenter view back up here. So we've also been integrating chatbots into this by mining our own chat logs. We've been using AI to train up our knowledge base on questions previously asked and documents like the Kubernetes and Docker stuff that we need to use. We have lots of documentation. Our documentation is constantly evolving, and we're a little aggressive about getting people to read our documentation. Students sometimes just jump in and cut and paste, and things don't quite work if you don't read the docs. So we're very much into evolving our docs. Available resources, we've been asked by our users to produce a whole bunch of different services. Jupyter Lab is one of the most popular ones. Etherpad was brought up for note-taking for meetings just like this. Early on, we had people wanting to do structure from motion, and we identified a WebODM as a tool that we could deploy in our cluster and scale it to as many GPUs as we needed. We also decided that GitLab, we wanted to host our own because the public GitLab, you can't do all the features unless you pay for it. But that's actually evolved in their services too. We also produce our own file sharing. We have a couple petabytes of storage. So we host our own Nextcloud instance. And we've created Traceroute Visualization tools, and we have lots of different file syncing utilities for moving data in and out of the cloud that we create. This is a Jupyter Lab. Recently, Jupyter Lab has been extended beyond all these different languages you see. There's also a thin remote desktop client. So you can get a Linux desktop inside of Jupyter. Very soon, that will be a GL accelerated or EGL accelerated Linux desktop where you can run Blender or Houdini in a Jupyter notebook. This is the Etherpad, just a very simple app that is kind of a scratch pad, very simple. WebODM, this is a little chunk of open drone map data that was loaded into our system. And this is just next to campus. And the WebODM instance has a cesium ion connector. And cesium ion just recently announced a plugin, a 3D geotile plugin for Unreal Engine. And that is releasing on the 30th of this month. So we're extremely excited about having a workflow that can take our drone data, tile it, texture it, and push it into a global texture registry. We can make it public and have them host it, or we can have that as our own private data. But we could actually contribute to the global texture. Like I said, we host our own GitLab GitLab is fabulous. The DevOps that we do inside here allow us to quickly build and evolve our code and push it securely in containers out to all of our servers and our edge devices. I have, yes, 417 projects current in my GitLab view. We have hundreds of users and thousands of projects, and it uses CI logon, so we don't own anybody's identity. We just use your campus single sign-on. One of our favorite repos is this EGL desktop I mentioned briefly. This is we started customizing a Docker that we found from NVIDIA that would do GLX acceleration. We wanted to run Houdini in containers, which is very difficult, and display that in a web browser remotely. And so Sungmin Kim from Kisti picked up our work and has evolved this EGL and GLX desktop into something much more reliable. And as of the next release of the NVIDIA drivers, the Wayland pipes will be all working. And so we'll get really clean GLX acceleration for all our games without having to be root in the container. This is an example of a build log of this, the continuous integration as it outputs. It finished building that container successfully, and we can review the logs. Very nice. And this is, every repo has a Git registry for housing your Docker image. So we're not pulling stuff from Docker Hub, so the performance is much, much faster. We also track all of our cluster issues inside the GitLab issue tracker. We can track every repo can have an issue, but we also have a repo for our cluster. And so when something breaks, we have automation that will post an issue to a person in the GitLab repo. So we've automated, hey, this machine just has a GPU that fried, go fix it. So that's very helpful. This is the Nextcloud interface. Again, we're using CI logon. You're going to see that everywhere. We don't want to own anybody's identity. We just want to know who you are and where you are. There's no anonymous anything in here. One of the Traceroute visualization tools we're going to go into in the AR knock visualization. This is our problem. We're a global network of spaghetti monsters. And so to understand what that knot means, we have to tweeze apart those nodes and edges and then overlay metadata. Those green and red and black and gray lines and yellow lines all mean something. And so we can get a visual wide area look at the performance of the network. This is the EGL or GLX container. This is Blender running in there. You can, oh no, sorry, this is Metashape from Agisoft. This is another structure for motion tool. Very, very popular. It can support multiple GPUs. Here you can see it's grabbed a hold of two 1080 Ti's, and I think it's running with 128 gig of RAM in a container in a web browser. You could never afford that in your laptop. They just don't fit. You could get up to 8 GPUs attached to that instance. And so that's a really kind of nice thing to have in the cloud. Here's Blender running. That was the easiest thing to get working. You just untar it and execute the file and it works. This is Houdini running. I have my neighbor Cody Harrington from Pixar stuff in the biggest smoke sim he can imagine Pixar ever wanting to do. And it's running at 120 frames a second in a web browser. So needless to say, Pixar, actually had a nice little call with their chief technology officer to figure out how they could support more remote work at home. They're having problems with their Teradici system, where it was stepping on MTU on wide area paths when it hit in Hurricane Electric's paths. This is
John,
Unreal.
let me just ask a quick question.
Yep.
That is a simulation running on Nautilus, displaying through a web browser as if it were a desktop.
This is Houdini running a smoke sim at 120 frames a second in a browser remotely It's probably got 128 gig of RAM and maybe a 2080 Ti GPU attached to it, maybe 2. I don't recall. But you can dynamically ask for as many as up to 8 for any instance. So it's very, very interesting tool. And then this is Unreal Editor running in that same browser. We're still working around.
All right, John, just to follow up on Jeff's question there, because I think I know what he was asking. I'm sort of curious too. With that last example, so the sim is running at 120 frames per second,
Yep.
but the actual refresh, is that what you could be seeing through the browser?
That's depending on how fast your connection is. It looks, the latency is extremely low. When you move that sim, it doesn't have any slosh to it. That's the problem they're having on the Teradici, is just tons of latency. Their mouse was getting stepped on by the video. And this does not do that. This buffering that happens, the GLX virtual GL to no VNC, there's a buffer in there that allows each client, you can have 10, 20, 30 people looking at the same web browser page, sharing that connection, all having mouse control, or you can give them a view only URL to look at it. But for collaborative editing, it's great. You can jump into a student's project and just start spinning and clicking and dragging their node graphs around.
Well, John, this is Lauren, if I could follow up one more question, what would you recommend the client bandwidth be? That is, the person on the end of this system sitting in front of their laptop on looking at their web browser. As a practical matter, what would you recommend? Anything.
We've tested this in both iPhone and Android phones. We've tested it in the Amazon Fire Stick. We've tested it in the, well, I'll get to that. There's the slide.
Okay, so it's a question about bandwidth, not compute on the client side.
No, it's totally asynchronous. It decouples. I mean, it'll give you whatever you can get, and it's still usable, no matter how crappy your device is or how low your bandwidth is. You can still
okay, please go ahead. I don't want to interrupt.
Too late. All right, so this is Unreal Engine. This is one of the harder ones. This is the full editor containerized in the browser. We have to run as root until we get the driver fixes and the EGL hooks from NVIDIA. But that's weeks away. We're really happy about that. So the next thing we have is our user portal. This is where the users come to interact with Nautilus. And so what we have on the left is before you log in, you get this kind of splash screen, gives you a couple instructions. All you got to do is click the little login in the upper left-hand corner, put in your campus user ID. You already have an account. You don't have to sign up. You just have to log in and identify yourself. Then once you're in, you have nothing. You have to be assigned a role in a namespace. This is all namespace driven. So you get invited to somebody's namespace, or you're an admin level person, and we give you a namespace admin role. And then you can create your own namespace and invite any user on the planet into it. And so that makes it really handy. We also have these namespace overview slides. So it's just a URL you can go to, and you can read everything about what they were willing to share publicly about what's going on with their namespace in our cluster. And we use this to automate reporting for Tom and Larry, so we don't have to go bug people constantly about, what are they doing? It's a minimum metadata standard that we apply to all the namespaces. Here is the namespace manager on the right-hand side, and you can search for your current namespaces, edit the descriptions or the institution or the software or the publications or your Git repos, and hit save. We also host dashboards. Everything in Kubernetes is graphed. Prometheus and Grafana give us unbelievable statistics, more than anybody could ever swallow in a lifetime. But when you're trying to find a problem, you can go dig into these finds and go find the little blip where you had a memory leak and it just out of memory crashed your container. Really fun. The best thing is, this is what Tom and Larry do. They take these graphs and tweeze apart all those little volumes, and these are GPU requests by namespace. And so you can see Ice Cube, that big brown slice in the middle, scraping up all the unused GPU time. They're a low priority scavenger of our excess resource. And so we very rarely have unused GPUs. But if a new job comes in that's high priority, those just disappear instantly. And as soon as that job finishes, they come back instantly. So they are absolute vultures. We also have a Perfsonar deployed on every single node in the cluster. And we do a mad dash. We've just started doing an all-to-all traceroute mesh to enhance our metadata about our node graph and our wide area networks. We have Inmon Traffic Sentinel collecting S-flow, again, put out on every single node in the cluster to give us IP packet level and system level statistics about every single thing going on in the cluster. We have Elastiflow, an elastic stack system that analyzes that data and tells us if we're getting attacked by DDoS or some type of brute force attack or whatever it happens to be, flavor of the month. We can also visualize the traffic between the campuses as flows, as bulk flows, as just massive traffic, but we're working on slicing those out to the individual science domains or individual workflows or individual grants. So the abstract can become physical. Here's the newest iGrok cluster, our Interactive Global Research Observatory Knowledge Base. This is a 7-node elastic stack cluster. It is there to receive statistics, logs, and then analyze, and then be searched on, and then acted on. So this is part of our AI feedback loop for how we react to problems in the cluster or the network. We'll have agents that mine the elastic stack for issues, and then the agent understands how to act on this. And here you can see the details of this is the metric beat that is just pulling in all the information about host level stuff. There's so much data available in Elasticstack. Again, years to digest. We also use a very cool tool called Netbox. This is our start of truth. This is where we store everything about the physical hardware. And we're using Ansible and Netbox together to create visualizations that we'll talk about in the AR NOC in the next talk. Netbox is an open source tool. It was introduced to me by Sean Amy from the Square Kilometre Array in Australia. This guy's got tens of thousands of computers spread across a desert. He needs to know where they are and what they're doing. And he suggested this is the best Swiss Army knife open source tool he's ever found. We're using a bunch of other tools for open source scheduling, federation, K3S for Kubernetes on IoT devices, and then some overlay networks and load balancer tools. The Admiralty is a decentralized multi-cluster control plane. It allows for federation from one cluster to multiple others in a master-slave, or cloud bursting where you're running on your own or bursting out to Amazon, or what we like is the decentralized federation, peer-to-peer-to-peer federation. I describe what I want to do on your cluster, you describe what you'll allow me to do. Everybody is in ownership of their own stuff. We have Perfsonar. These are cases that we can do for federation. We're right now currently building ARM containers on an ARM cluster using our GitLab system, but it does it using a federation layer where it sends an ARM container to an ARM server for compiling the Docker file. And then it returns that back to the primary. I'm going to skip over the other examples. Here's the IoT example where this is the IoT cluster where I have all these devices out in the field. On the lower left is a Google Edge TPU PoseNet deployment that we're working on for markerless tracking of multiple people in a space. And that is, well, again, I'll go back into that in the next talk, but we're going to use VRPN controller technology to hook up to the human as a human controller. And this is another example of the successful federation The Wi-Fi workflow is federated from the Expanse supercomputer at SDSC into Nautilus for GPU processes and some other things, and then returns the results into the Wi-Fi process. And those who want to really have fun, we do layer 2 OpenNSA auto goal 100 gig layer 2 switching into these same containers on this virtualized Nautilus cluster. So we can provision extremely high bandwidth across ESNet, Scenic, and multiple domains across the planet. I'd like to thank everybody.
Wow, John, that's great. And I know it was a little bit hard to stick to just those few examples. We have a few minutes for questions. Does anybody have any questions? And I'd like to remind everybody that we will make these slides available offline.
Quite a bit in there. I did, in this first deck, I put lots of links, URLs, and speaker notes. So if it's hard to chew on, it'll be a little easier if you just.
So John, maybe you could.
I have a question.
Yeah, go ahead, Richard.
So John, that's great. And it looks like you're wearing this big AI thinking cap. It looks wonderful behind you there. I had a question. So you showed Houdini running in this, the web browser window.
Yes.
There are other 3D animation programs like Maya and Cinema 4D. Is there anything special about Houdini that allowed you to do it, or could it just as well have been?
No, I wanted to use Houdini as part of our pipeline. Houdini has an Unreal plugin. Houdini also has OpenStreetMap and MapQuest plugins. They came out before the ArcGIS plugin for Unreal did, or the Cesium plugin that's coming out on the 30th. So we're really, really, really early on in Unreal true GIS. As a matter of fact, right now, they have to do some fakey math in a library because Unreal is a 32-bit app, and you have to have 64-bit to do floating point for GIS. And so they have a faker library right now that is going to be replaced in the next version of Unreal 4.27. It's all 64-bit, the whole app.
So my curiosity about that was piqued because I know that Houdini is the application that they use at NCSA to make those beautiful galactic visualizations and those things that go from the galaxy all the way down to the mitochondria.
Yep.
And one of the areas that I'm looking at for and sometimes those renders take many cycles on a supercomputer. But it turns out that you might be able to apply some AI there in ways that help you do noise reduction without constant resampling. So it's very interesting that Houdini could be part of a larger pipeline that might include these kinds of AI-enabled optimizations.
Right. Unreal just, there's a plugin from NVIDIA called DLSS, Deep Learning Super Sampling. And basically, you just add this free plugin to your game, and it decides how to sample and render. And it can bump your frame rates from like 30 or 40 to 100 frames a second without losing any res. And it
actually improving the res.
Exactly. It'll render fur on your meerkat in the shades where there was none before.
And so, John, I just want to make clear for everybody who doesn't speak acronyms as rapidly as you do, that GIS means
Geographic Information System,
also known as mapping and remote sensing.
Yeah, it's an overlay on the Geographic Information System.
Well, if there's no more questions about the bombardment of how John operates and does the tools, we had that wonderful presentation from Tom DeFonte last month, laying out the sort of higher level organization and motivation behind Nautilus. And we asked John to come back and talk about the tool set. if somebody wants to do machine learning and DevOps and all these wonderful things that John's supporting, then here's a candidate tool set. And if you want to use Nautilus, this is the tool set that comes with. So we asked John to give actually 2 talks today. And John, if you want to shift to your second talk, we'll jump right in.
Certainly. Let's see, where did I hide that browser? Oh, there it is. This over here.
You know, John, before you go, John, I'd like to welcome some of the people who came a little after you started. So Darcy, you want to say hello? Dan Sandine, you want to say hello? And Gary Thompson?
Hello.
Hi.
Usually it goes like, hello, this is Dan Sandine, I'm where?
All right.
Hey,
I'll
Dan,
start.
I just saw a good picture of yours. I forget what I was looking at, but I saw a very nice picture of yours someplace. This is Darcy. I'm in the Catskill Mountains.
Wonderful.
Cool. Hi, I'm Gary Thompson. I'm up in San Francisco at ILM right now. And amazing presentation. So much information there. It's definitely
Great to see you, Gary.
Yeah, good to see you, Lauren. And
Welcome back.
More fun.
thank you.
We're getting the band back together, Gary.
I missed the last one, unfortunately, but I'm sort of working on the side here. We're pretty busy, but this is
Of course. Thanks for your time. And Andy Johnson, has no microphone at the Electronic Visualization Lab in Chicago. And Jürgen?
Yes, hello. I'm here in San Diego. I'm a research scientist at UCSD and work on virtual reality with Tom DeFonte.
And Wayne? Thanks, Jürgen. Wayne Smith?
Oh, I'm just a guest. I work at Cal State Northridge, and I help faculty with computationally intensive, storage intensive, IO intensive projects. And I'm just a beginning Nautilus user, but working on it every day.
And Mount Allen? Thank you, Wayne.
Greetings, Mount Allen, and I'm with the San Francisco Jazz Organization, SF Jazz, operating on the CineGrid network and playing with lots of collaborations across the country and the world, musically.
Terrific.